Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at factorizing and solving cubics. So a cubic is a degree 3 polynomial. That means the highest power of x is 3 and any other power of x is a positive integer. So we are going to solve this equation through factorization. We're going to write the cubic expression as something times something times something so that we can use null factor law. So there are a few different methods of factorization. I'm going to start by going through highest common factor. Use that when the terms have a common factor. So these three terms each share a common factor of 2x. So how we do highest common factor, we write the common factor out the front. Now we say, what do I times by 2x to get 2x squared? You need to times by x squared. What do I times by 2x to get negative 8x squared? Well, you need to times by negative 4 to get the negative 8 and another x to make it x squared. What do I times by 2x to get 6x? That's just 3. So the idea with factorizing cubics is we reduce it to something times a quadratic because we already know how to factorize quadratics. That's pretty easy. So I'm going to leave the 2x alone here. Now to factorize this monic quadratic, we find two numbers that multiply to this and add to this. And those numbers are, of course, negative 3 and negative 1. So now what we have is a bunch of things multiplied together to equal 0. So the null factor law says either the first thing equals 0, so that would mean x is 0, or the second thing equals 0, giving x equals 3, or the third factor equals 0, and that would mean x equals 1, and we're done. The next method of factorizing I'll show you is grouping. So we're going to solve this equation. Now, whenever you're solving a polynomial equation, be it cubic, quadratic, or whatever, first we need to make sure one side is equal to 0. So here I'm going to subtract from both sides the 3x squared. I'm going to subtract the x and add 3 to both sides. We need one side equal to 0. Now, when we use grouping, this is a method you would be familiar with. You would have used it when you factorize non-monic quadratics. What we do is we group the terms. We group the first two terms and the second two terms. We're going to factorize these two separately and then factorize these two separately. So for the first two terms, we'll use the highest common factor method here. The highest common factor of these two terms is x squared. So we write that out the front. Now what do I times by x squared to get x cubed? X. What do I times by x squared to get negative 3x squared? Negative 3. These two terms have a highest common factor of 1. If this term is negative, however, always take out a negative factor. So I'm going to take out a factor of negative 1. So what do I times by negative 1 to get negative x? Well, I times by x. What do I times by negative 1 to get positive 3? I times by negative 3. So now it's like we have two things, this and this. They share a common factor of x minus 3. So I write that out the front. And what remains, the x squared minus 1, that goes in the second bracket. So I have successfully factorized this expression, but I can actually factorize it further because this quadratic can be factorized. It's just the difference of two squares. So the way we factorize difference of two squares, we get two brackets, square root the first square, square root the second perfect square, one gets a plus, one gets a minus. So once again, we use the null factor law. Either the first bracket is equal to 0, the second bracket is equal to 0, or the third bracket equal to 0. So when you have a cubic equation, there will always be 1, 2, or 3 real solutions. So we know there can't be any other solutions. There can never be more than 3 solutions to a cubic. All right, let's look now at one more method for factorizing cubics. So this method is the sum or difference of cubes. So this tells you how to factorize the sum of cubes and this the difference of cubes. So using this formula, we get a linear factor, but we always get an irreducible quadratic. So this quadratic and this quadratic cannot be factored further, at least using real numbers. So if we look at something like this, I'm just going to factorize here, not solve. We have something cubed plus something cubed. This is the sum of cubes. So I could just write this as x cubed plus 2y all cubed. So this is like what I'm going to replace with x in the formula, and I'll replace y with 2y in the formula. So the formula for the sum of cubes, it's just going to be x plus 2y multiplied by x squared minus 2xy. That's the two terms being cubed multiplied together, and finally we will have 2y all squared, so 4y squared. So if you expand this, you will get this. We can't factorize this quadratic any further. So let's try this one. So this one's actually a degree 4, a quartic, but we can use the methods we've just used to factorize it. See, these two terms have a common factor. You should always try to use highest common factor first. We couldn't use it in something like this. There is no common factor. But here, there is a common factor of x. So we're going to start by writing x out the front. What do I times by x to get x to the power 4? Well, that's x cubed. What do I times by x to get the second term? Well, that's negative 125. Now here we have the difference of cubes. This is obviously a perfect cube. This is 5 cubed. So using the second formula up top, this will be x minus 5 multiplied by x squared. Now plus xy, so y here is 5, so this will be a 5x. And then y is 5, so y squared will be 25. And as I said, this quadratic will always be irreducible, so you can't factorize it further. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.